This slide shows the fitting of the first order model. So, for example, if the process reaction curve is given by the figure below here, we can estimate the process model as a first order system. So, if we look at this response, the x-axis represents the time domain, which we represent the response, the time through tau, 2 tau, 3 tau, 4 tau, and 5 tau. And the y-axis is represented by y over km, which means the normalized output. So if the value is 1, meaning that the response, the output, has reached its final steady state value. So this is the response of the system. It started due to the step input at 0, and here is the response. So red color represents the step input, and then the black response is the output. So if we look at the previously described output response, we can observe that we need to find two parameters, which are the process gain K and the time constant tau. So in solving this equation and to find the process gain and time constant, we will first evaluate the initial slope of the response. So this is the slope that we can estimate, which is the maximum slope that occur to the reaction curve. If I can plot the curve, the slope is like this. So the slope is represented by this blue line. The first point will be at the initial value where the step start. So that is the first point. The second point is by adjusting this slope and find what is the best slope to represent the maximum slope of this reaction curve. So let's say if we look, this is the best maximum slope of the curve. So theoretically, or from this figure, we can see that the maximum slope is obtained and crossing the final value. If we sketch this slope, we can get the value of slope is 1 over tau. So 1 is the value of normalized magnitude and over tau. Yeah? So tau is the the x-axis. Therefore, what we can learn from this equation that the slope is equivalent to 1 over tau. So in order to find what is tau or time constant, we can simply rewrite this equation because the slope is obviously can be calculated, and definitely we can solve what is the value of tau. The next is to calculate what is the gain. So the gain can be calculated from the steady state changes in input U and output Y. So K is equivalent to delta Y over delta U, which in this case the output is delta Y over the input. Input is given by M, and we already know what is the input to the process, the magnitude of input, and the final value of Y can be measured from the output. So by using these two values, we can calculate what is the K or the process gain. So that's how we can fill up this equation and we can represent the process that producing this curve. So that is how we fit the first order model by using empirical modeling for first order system.